This lesson is trying to teach you how to construct ionic equations to represent the dissolution and precipitation of ionic compounds in water. This word here, dissolution, that's the word that we use to describe something dissolving in water, so the process of something becoming a solute. And precipitation is the opposite. Precipitation is the process of two aqueous solutions coming together to form an insoluble solid, and that's what we call the precipitate. So the best way to do this is to kick straight into a problem. So here we have problem 1. Predict whether a precipitate will form if aqueous solutions of silver nitrate and sodium chloride are mixed. If there is a precipitation reaction, write the complete and net ionic equations to represent this. Now, in all of our precipitation problems, we need to have our solubility rules there as well. So here we have down below our solubility rules, and these will be given to you in an exam if they're needed. But you'll get to know most of them anyway as we go. So the first thing we need to do is work out what we have and try and predict what our products will be based on what we're starting with. So we first need to write the chemical formula for each of these two compounds here, our ionic compounds. So we've got silver nitrate. Silver usually has a valency of 1, and nitrate also has a valency of 1, so AgNO3, and we are told that that is an aqueous solution. And that is being mixed with sodium chloride, also aqueous solution. Now, in our precipitation reactions, what happens is that first these compounds, these ionic compounds, are dissolved or into the water, and so that they become ions, and then those ions actually sort of swap partners. So what we end up with is we end up with the metal of the first joins with the non-metal of the second, and then the metal of the second joins with the non-metal of the first. So we end up here with silver chloride and sodium nitrate. Now, to work out which one of these products is aqueous and which one is the precipitate, is we need to go back to our solubility rules. So looking at them below there, okay, so here we can see all chlorides. We've got silver chloride on this side. All chlorides, bromides and iodides, are soluble except those of silver and lead. So we've got one of those exceptions here. We've got a silver chloride, and that means it's insoluble. So we put our symbol for a solid next to it. It's not aqueous, it is an insoluble solid, and that's our precipitate. And then we need to work out whether this over here is also a precipitate or whether it's an aqueous solution. So we've got sodium nitrate. Here we've got all sodium, potassium and ammonium salts are soluble, and to back that up we've also got all nitrates are soluble. So we have a sodium nitrate, definitely soluble. So that is aqueous in solution. Move that over so you can see it. There we go. Now, the next thing we need to make sure of is whether this equation here, this is our complete ionic equation, whether it's balanced. And from looking at it, it is balanced, so we don't need to do anything. That is what we call our complete ionic equation, that one right there. And to be a complete ionic equation, you must include all of your symbols as well. Don't leave any of them out. Now, a net ionic equation. Think about a net ionic equation as, you know, if you're going fishing, the thing you catch in the net is what you're really interested in, okay? You want just the fish that you're getting in the net. You don't want the seaweed and other things around it. You just want the fish. Now, in this instance, we are talking about the components of the reaction that are actually reacting. So we want to eliminate this, what we call spectator ions. So to do that, we're going to split all of this up into ions, and we're going to see what happens on either side of the equation. So here we've got Ag+, that's aqueous, and our nitrate, and they're both aqueous. Okay, that's the first side of the reaction done. Now notice that I've put that remember these are being dissolved into water, and they're being mixed up together, which means that we don't have these anymore as a solid or a compound. Then we now have the ions in solution, and those ions are moving about the solution. That's why I've written them with their signs above, because they are ions. They're not compounds at this stage. On the other side, remember, the precipitate, because it's a solid, this is not being dissolved. It's insoluble, which means that we write it as a solid on this side. We can't split it up into its ions because it is a stable compound now. But the sodium nitrate is not, so we can split those up into their ions. If you can't see, I just wrote that it's aqueous over there. All right, so now what we're looking at is anything that doesn't change on either side of the equation. So I can see that on both sides of the equation, nitrate is in aqueous solution. So that hasn't changed, which means it hasn't actually been involved in the precipitation reaction. The other thing I can see that hasn't changed is the sodium. This sodium and this sodium, they are the same on both sides. Now what has changed is the silver has gone from being in solution with a positive charge to being neutral with no charge, because now it's in a compound as a solid. So it has had a change of state, okay? And it's no longer an ion, it is now neutral as part of this compound over here. So our net ionic equation, and we can see here the chlorine has also had the same thing. It's gone from an aqueous solution into a solid. This is our net ionic equation. Our net ionic equation. Okay, it's only what we want. We have eliminated our spectator ions up here. That's not what we're interested in. So our complete ionic equation, that has everything including spectator ions, and in our net one we only have exactly what we want, nothing extra in there. So let's try one more problem before you are to do it by yourself. I'll go through this one a little bit faster than I did the last one. All right, here we go. Problem 2. Predict whether precipitate will form if barium chloride and sodium sulfate are mixed. Write the full and net ionic equations for the reaction. Okay, let's start off with writing the chemical formula for these two compounds. We have barium chloride and sodium sulfate. And just like we did in the last one, remember they swap partners. So the metal of the first joins with the non-metal of the second, and the metal of the second joins with the non-metal of the first. And so what we end up with is barium sulfate. They both have a valency of 2, and sodium chloride, they both have a valency of 1. Let's just quickly balance this. So I've got 2 there, I just need to put a 2 here, and now I've got a balanced equation. And now we need to figure out which one is our precipitate if a precipitate has formed. Remember, you might be given an example where there is actually no reaction, there's no precipitate formed. So let's have a look here. Okay, we have a barium sulfate. Here, all sulfates are soluble except lead and barium. So here we've got one of these exceptions, barium sulfate, that is actually forming a precipitate, our solid. It's insoluble. The other one, we've got sodium chloride. All sodium, potassium, and ammonium salts are soluble, and all chlorides are soluble. So we've got a sodium chloride, it is definitely soluble, it is aqueous in solution. So that there is our full balanced ionic equation for this reaction. Now we need to do our net ionic equation. So like we did before, we're going to split them up into their ions. We've got barium. Barium has a valency of 2. So here we've got 2 plus. It's aqueous. And here we have Cl minus, but we've actually got two of them. And what that means is that in solution, for every one barium atom, we've actually got two chlorine atoms. Okay, so we've got one barium for every two chlorines. So here we've got one barium, splits off, and it has a +2 charge. And then we've got two chlorine minuses for every one of these. That's why the 2 comes out the front. That's also aqueous. Let's do the same thing here. Now we've got 2 Na plus for every SO4 2 minus. Again, that's saying that we've got 2 of these sodium ions for every 1 of the sulfate ions. Now remember, solid doesn't split up into ions. It is a solid precipitate. It is not ions. And over here we've got 2 of these and 2 of those, both aqueous. Now we can see that that works because we've got a balanced equation. We've got 2 chlorine ions, 2 chlorine ions, 2 sodium ions, 2 sodium, and so forth. Now, this is where we look for our spectator ions. So what actually don't go through any changes over here? So I can see I've got my chlorines. They have remained in aqueous solution. There's been no change there. And I can also see my sodiums are the same. No change, haven't changed state, have the same charge, all fine. So that means our net ionic equation is our barium ion collides with our sulfate ion to create the insoluble solid barium sulfate. And this here is your net ionic equation for that reaction. So what I'd like for you to do is write down a couple of steps that you should go through based on this video for any type of problem involving precipitation reactions, and the steps you go through to write down your full and your net ionic equations, and then you can do some extra questions that are in your homework doc. Thank you.